Thomas L. Cosby, Black inventor. Improved upon the rotary engine and invented a variety of other engines. He invented the isolated vapor cycle engine on August 7th, 2003, filed on February 4th, 2002. The abstract says a single-phase vapor cycle apparatus has a reservoir containing a supply of heated vapor, a turbine for producing a work output, and a compressor downstream of the turbine. The turbine receives the vapor from the reservoir and expands the vapor at an incoming temperature and pressure so that the vapor is exhausted from the turbine at a first temperature and pressure below the incoming temperature and pressure. The compressor receives vapor exhausted from the turbine. Heat is exchanged between vapor entering the compressor and vapor being compressed in the compressor so that the vapor in the compression process is cooled and the vapor entering the compressor is heated to a temperature above the first temperature. The compressed vapor is delivered to the reservoir. He also invented the unitary turbine compressor engine on May 6, 1997, filed on March 4th, 1996. The abstract says, a work-reducing composite engine system that uses ambient air for a primary energy source. The device consists of a unitary turbine compressor assembly utilizing a turbine for producing work output and a downstream compressor for receiving fluid exhaust of the turbine and for compressing the turbine exhaust. An internal heat exchanger is provided between the turbine and the compressor so that fluid in the compressor is cooled, thereby reducing compression work requirements, and the turbine exhaust is heated by the compressor, thereby decreasing input heat requirements. He also invented the maximum ambient cycle on April 28, 1992, filed on January 9, 1990. The abstract says, a system comprising a high-pressure gas reservoir, a turbine, a compressor, a low-pressure reservoir, a heat exchanger, and a flow control structure, such as valves, etc. The high-pressure reservoir is in heat exchange relationship with ambient air and delivers fluid at ambient temperature to a turbine. Spent fluid from the turbine exhausts and is brought into heat exchange relationship with the compressor. The compressor exhaust is at a temperature above that of the turbine exhaust. The exhaust, which is heated by the compressor, is then delivered to a low-pressure reservoir, which is in heat exchange relationship with ambient air, and from there the exhaust heated by the compressor is delivered to the compressor inlet. He also invented the closed-cycle external combustion engine on May 12, 1987, filed on May 7, 1986. The abstract says, an external combustion engine which utilizes an impulse or velocity compounded turbine in conjunction with a compressor to reduce input energy requirements while delivering an increased work output. The invention is characterized in the use simultaneously of cooling and compression significantly to reduce the compression work requirement of current practices, which utilize interstage cooling between compression cycles. In accordance with the present invention, the fluid is cooled in the compressor itself during the compression cycle, and heat energy losses inherent in conventional cycles are reduced. The efficiency of the engine is increased significantly. An important feature of the invention is that phase change or transformation is eliminated so that heat energy is conserved. In a second embodiment of the invention, the engine utilizes one or more impulse or velocity compounded turbines, and expansion is limited to a range in which compression is carried out with a minimization of parasitic losses.